explain what I learned from I visited ISRO in October 6th. Just I will give about the basic introduction of the remote sensing and technology used in the agriculture fields. So normally the remote sensing and definitions shows the art of science of obtaining information about an object or feature without physically coming in contact with the object or features. That means we have to know the information of the particular object without any physical contact. The sensors, it should be mounted in an atmosphere, it should be running in the atmosphere. They take the picture of the ground features without any help. Only the sensors, they cover the take a photo and send it to the ground platform. Then it should be converted into the normal pictures. So remote sensing can be used to measure in the form of variation in aquatic wave distributions, variation in force like a gravity meter, variation in electromagnetic energy distribution. So all the objects in the earth features are observed with the help of the variation in electromagnetic energy in the field of spectrum only. So remotely collected data through the various sensors may be analyzed to obtain the information about the objects or the features under investigation. So remote sensing is detecting the measuring the electromagnetic energy or reflect the distant object made of various materials, so that we can identify the categorize the objects by class, type, the suspensions and spatial distribution. Like that, whenever the remote sensing is detecting, it may be a, whether it should be a reflector or whether it should be a transmitter. With help of them, we have to identify the object of the ground features with help of the remote sensing. So generally, the wavelength of the radiation, it should be explained E equal to HCF, where H equal to Planck constant, then speed equal to speed of the light. That is whether it should be depend on the source, whether it should be a normal or whether it should be artificial. A normal source example is sun. For artificial, we have a special lighting provisions in there. Then F equal to frequency expressed in hertz, then lambda equal to wavelength in micrometers. So this is the typical EMR spectrum. So normally in visible light up to violet 0.4 to near infrared, this is the range the electro energy experienced in terms of the wavelength lambda. Most of this range only we have to identify the S features or particular object in the earth. So in terms of the principles of remote sensing, we have the sensors. It is a device used to collect the reflector or emitter electromagnetic radiation. Example like cameras and scanners. So similarly, the platform, a vehicle used to carry the sensors. So where are the stages in the remote sensing? First one shown in the picture, it will be A, the emission of electromagnetic radiation from the sun. Then B, transmission of energy from the source of object, whether it should be transmitted or reflected. Transmitted means it will be from the features underneath the ground features. Once it should be reflected in the form of D, then it will be reach the sensors. Then finally it will be get the ground platform through F. Then finally the data it will be analyzed. That is the C. Then D. Then E, recording of the energy at sensor. Then S, F, a transmission of recorded information to the ground station. Then H, processing of data into digital or hard copy. Then finally we have to analyze with the ground help softwares. So similarly, the passive remote sensing or active remote sensing. So passive remote sensing means taking picture with a ordinary camera. Then active remote sensing means taking picture with the camera inbuilt flash. Example, if the ordinary camera, it will be take the picture only during the sun. So in the night time, it will not take the picture with unclearness. When go for active remote sensing, it is a camera fitted with a flash, so we can take a picture even in daytime and day and night time. So these are the some of the sources of energy that are available for the passive remote sensing technology. Similarly, active. So what are the platforms? Based on the remote sensing technology, ground level, then aerial, then spaceborne. So it depends upon the altitude. At what altitude we have to measure the object, whether it should be a ground level very close to the ground, or develop the calibrated sensor, then different features on the surface. Suppose aerial means whether it may be a low or high altitude. Similarly, space shuttles and polar orbiting satellites, then geostationary satellites. Some of the airborne remote sensing, it should be downward or sideward looking sensors mounted on an aircraft are used to obtain the image or spatial resolution 20 centimeter or less than can be obtained. So, in general, LiDAR along with the aerial photograph with thermal imagery digital photography are commonly used in airborne sensor. Similarly, spaceborne, geostationary and polar orbit. Geostationary and polar orbit means geostationary, it will be rotating, it should be collecting the data from the earth around 35,000 km away from the earth's surface. Similarly, polar satellites means it should be rotating 90 degree to the earth surface. So these are the basic components of ideal remote sensing. A picture A, it will be shown the energy, whether it should be a sun or whether it should be artificial. Then second one, the non-interfering atmosphere. If it is non-interfering atmosphere, the wavelength from the sources, energy sources, it will be transmitted and reach the earth surface, and some of the part it will be reflected, then some of the part will be transferred, which depends upon the earth features. Then third, a series of unique energy matter interaction at the earth surface. Then fourth, once it should be reflected, a sensor will receive the details of the reflected frequency mode. Then finally, a real-time handling data system and multiple data users here to conclude the features on the earth surface, it should be identified. So a basic components of ideal remote sensing system, a uniform energy sources, then second one, a non-interfering atmosphere, then third one, a series of unique energy matter interaction at the earth surface. Similarly, a super sensor, already I told you, a real-time data handling system, then multiple data users. So some of the major advantages of remote sensing are provide data for large areas, provide data of very remote and inaccessible regions. Suppose if you are maybe inaccessible means there may be a forest areas, the dark tree sites, you cannot go and identify the features in manual. So in that we have to use the remote sensing data, remote sensing system, then relatively inexpensive when compared to employing a team of surveyors, then easy and rapid collection of data, then finally it have the rapid production of map for interpretation. Some of the drawback, the image require a certain skill level, so need a cross verification with the ground. So whatever the data we collected with the help of the remote sensing, finally it will be whether it should be matched with the field ground level or not. It should be it to be identified. The data from multiple sources may create confusions. The object can be misclassified or confused. Then distortion may be occur an image due to the relative motion of sensors and sources. So some of the spectral reflectance curves, because the regional remote sensing center Bangalore, it will be only gone through about the agriculture fields. So in that they are give some introduction about the spectral reflectance of the vegetation, then soil and water. So spectral reflectance means it is the ratio between the wavelength reflected from the object to the wavelength incident on the object. It will be give the reflectance, with based on the reflectance it could be identify the particular type of object. So this is the spectral curve for vegetation. We will see that in that first one it will be seeing the picture from arrow mark, it will be indicated healthy green of vegetation. Then once the wavelength move up to the 1.4 and above micrometer, the vegetation level is reduced. The good absorption of visible range is 0.7 to 0.4 to 0.7 micrometer. So absorption reduces and reflection increases, boundary near 0.7. So reflectance is nearly constant 0.7 up to 1.3 micrometer. For reflectance decreases for long wavelength when compared to the short wavelength. So similarly it will be to the same pictures, the healthy green vegetation of the particular area. This is for soil, dry bare soil. So the reflectance of a soil considerably less peak and value the variation compared to that of vegetation. So the factors, some of the affecting the reflectance of soil, first one moisture, the second one the structure, like proportion of sand, then silt and clay, then roughness of soil, similarly the iron and organic matter in that particular soil, it will be affect the reflectance curve of a particular soil. Then similarly water, so normally the water wavelength up to 0.4 to 0.6, it should be a wavelength beyond 0.7 micrometer completely, it should be absorbed. Similarly the pictures shows the reflectance of the some of the area, the part of Krishna river basin, different Landsat imaginary, up to the band level of 0.45 to 0.52, then 0.5 to 0.6, then 0.63 to 0.69, similarly 0.7, 0.9, up to ground resolution will be take. So even in that particular regional remote sensing, the AL and machine learning also it should be included in that regional center. We have to identify the aquacultures or the ground features with the vegetation, soil and water categories are analyzed with the help of the machine learnings. These are some pictures. Thank you, one and all.